So in the next part of the review, we're going to look at how to make graphs of trig functions. So the first one is a cosine curve. It has an amplitude of 6, and it has a midline of 2. Now, one thing you'll notice on this graph is that if our amplitude is 6, we're going to go like flying off the graph very quickly. So I'm going to relabel my axes right away to go by 2's, and that should give us enough room. So -2, -4, -6, -8, -10. I shouldn't have to do anything to the x-axis, so that's still going to be our standard -2 pi to 2 pi x-axis. So I'm going to put in my midline here at 2. I know that a cosine curve normally starts above the midline, and because the amplitude is 6, I'm going to start 6 above. So I'm up here at 8. You'll notice that I didn't have to go left or right at all. There's no horizontal shift in this graph. I do need to start thinking about the cycles and the period. So two ways to think of this. This 2 tells me there are 2 cycles within 2 pi. So it means I have to make 2 of these curves. Or if I use the formula 2 pi over b equals the period, in this case we've got 2 pi over 2 equals pi. So I need to come up with, however you think about this, the cosine graph. So if I go every half tick mark, I'll have to go down 6 to here, up 6 to here, up 6 to there. And you'll notice that by going every half tick mark that I've done 1 full cycle in pi, so that means I'd get 2 full cycles within 2 pi, which is what was desired. So down 6, up 6, up 6. And this is all I'm going to draw for this one. I can draw more than 2 periods. Just always pay attention to the directions. If it says you need to draw at least 2 periods, draw at least 2 periods. Alright, so that's graph number 1. Graph number 2 is a secant graph. And so secant, you need to know, is related very strongly with cosine. The information we're given here is that we have a cosine curve that has a horizontal shift of pi to the right. So here is where pi to the right occurs. I'm going to mark that there. There's no vertical shift. And it's a cosine curve, so normally it would start above the midline by 1, because that's the amplitude. But here I'm going to start down 1. There's no change in the period, so I can just go 1 tick mark at a time. Now what I'm drawing here is not the actual graph that we want. This is just the graph that's going to help us make the secant graph. So what you should know at this point is that for a secant graph, all the asymptotes are going to be where the graph of cosine crosses the midline. And then to make the secant graph, what you do is go to every max and min, and you make a bunch of u's. And the u's should be hugging the asymptotes. So that would be our secant graph. The next one we're supposed to do is a tangent graph. And so for tangent, you'll notice there's no horizontal or vertical shift here, so that's nice. We're going to start right on the y and x axis. And you need to know that tangent starts on the midline. So we're going to have a point right there. The next important thing to know is what the period is. Remember, for tangent, the period is pi over b equals period. So here, the b value is just a 1. So that means that we've got pi over 1, which equals pi. What that tells us is this is our starting point. If you go pi away, we need to have another starting point, and we can keep repeating that. The asymptotes for tangent always show up in between those midline points. And now to finish off the tangent graph, you need to know that tangent normally goes upward, but because it's a negative tangent, it's going to go downward. And if you want to make your graphs really nice, we're going to use the 3 to tell us how tall it is. So if I go down 1, 2, 3, and then halfway to the asymptote, and up 1, 2, 3, halfway to the asymptote, I'm going to have a pretty good graph. So you want to kind of go like this, and then like that. And I'll do another one. So that would be 2 periods of that tangent graph. And you, of course, could draw more. Here is a cosecant graph we need to do. So once again, we want to rewrite this as a sine function and look at what that looks like. So for this one, we've got a vertical shift down 1. So here's my midline. And we have a horizontal shift of pi to the right. So I'm going to mark that right here. Since I have a sine curve, I'm going to start at this point, the horizontal shift and on the midline. It has an amplitude of 3, so I'm going to have to go up 3 for the first point, and there's no period change here because b is 1, so I'm going to go 1 tick mark at a time. So up 1, 2, 3, down 1, 2, 3, and then continue the process. 1, 2, 3, 3, 1, 2, 3, 3, 3, 3. Once again, this is not the actual graph we want. This is just going to help us make the graph. So the actual graph we want is going to have asymptotes where the sine curve touches the midline. And then we're going to have u's coming off of the maxes and mins. All right, 2 more graphs. We've got y equals -2 sine 2x plus pi over 2. So this one's going to be a little bit ugly, but it has an important idea in it that we need to review. And that is we need to factor out this 2 that's in front of the x from the inside. A lot of people think pi over 2 is a horizontal shift here, but it's not. So if we factor out that 2, what we're left on the inside has to be pi over 2 divided by this 2. And if you divide pi over 2 by 2, you're going to get pi over 4. So this isn't going to be hard, but it's going to be a little bit off the graph. So we have a horizontal shift of pi over 4 to the left. Pi over 4 is right about there. We have no vertical shift, and because it's a sine function, we're going to start right on the midline. All right, so here's where you're going to have to pay attention a little bit. This says that we have a compression by a factor of 2. So it means we get 2 cycles within 2 pi. If you remember when we did this before, that means I was going every half tick mark. So from here, I'm going to be going a half tick mark down, half tick mark up, half tick mark, over and over and over again. And to see that that worked out, if you look at this, from here to here, that would be a distance of 2 pi. If you're having trouble seeing that, the distance from here to there is 2 pi, and this graph is just kind of like smushed over a little bit. Pi over 4 to the left, actually. So, yep, this is working right. And if I wanted to continue, I can. So up, down, down, up, down, down. So a little bit tricky, but that's what our sine graph is going to look like. So for the last one on here, we've got a cotangent graph. We know right away that it has a horizontal shift of pi over 2 to the right and a midline at y equals 1. I should put that line right there. Now for cotangent, you need to know that it starts with an asymptote. So it turns out right here is where its asymptote is going to be. We need to know the period. For this one, there's no period change because b is 1. So remember, for cotangent, it's pi over b equals the period, not 2 pi. So we've got pi over 1 again, which equals pi. So if you go pi away from this asymptote, you will find yet another asymptote. So we're going to have all these asymptotes pi away. And now what you have to remember is, on the midline, in between those asymptotes is going to be a point. Next, remember that cotangent goes downward, not upward. And if we want to be really precise, there's a 1 here in front of cotangent, so that means we'll be going up by 1 halfway to the asymptote each time. But as long as you showed me a graph that did this, I'd be pretty happy. And that's good enough. All right, and that finishes the second page of the review.